Start with you, not with your relationship, not with your job, not with your money, but with you. Good morning to one and all present here. On behalf of PG and Research Department of Mathematics, DG VAISHNAV College, I welcome all the PG students and CSIR aspirants. Pray, then you let it go. Don't try and manipulate or force the outcome. Just trust God to open the right doors at the right times. Now, Tamutal Varthu followed by college prayer.
சீராரும் வதனமென திகழ்வரத கண்டமிழே எக்கணமும் அதிசிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை முதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம் மிகுந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
சத்யவ்ரதம் சத்யபரம் த்ரிசத்யம் சத்யஸ்ய யோனிம் நிஹிதம் ச சத்யே சத்யஸ்ய சத்யம் ருதசத்யநேத்ரம் சத்யாத்மகம் த்வாம் சரணம் பிரபன்னாஹ. வாணி குணானுகதனே ஸ்ரவணோ கதாயாம் ஹஸ்தௌ ச கர்மசு மனஸ்தவ பாதயோர்நஹ நிவாச ஜகத் பிரணாமே சுபவத்தனூனாம். நமோ பகவதே தஸ்மை கிருஷ்ணாயாத்புத கர்மணே ரூபநாம விபேதேன ரூபநாம விபேதேன ஜகத் கிரீடதி யோயதஹ. ஓம் சாந்தி சாந்தி சாந்தி.
This is C4 workshop, Chase, Crack, Conquer, CSIR Net, which will make the CSIR aspirants to go to the next level. Today, our resource person, Planter Association College, Bodi Naik. Now, I hand over the session to you, sir.
Good morning to everybody. My dear postgraduate students and research scholars, yesterday we had seen one part of probability theory, that is the root of statistics, and I started with set theory and probable, that is set function, and then how the even set can be formed and how the probabilistic model can be formed, so that we can solve all the problems, probability-oriented real-life problems. Today I am going to introduce a new concept that is called random variable. Most of our mathematicians or young students do not understand, they are unable to understand what is random variable, what is the use of random variable. Because when you want to solve a problem in probability theory, we need probability solving skill. That is a little bit of probability formula and counting techniques. And then you do divide, take the ratio of two things, number of favorable events divided by number of favorable cases divided by total number of cases. That will give you the answer. So what is the need of random variable here? What part it takes in solving probability problems? That is very much important because yesterday I told you an example, that is lifetime of a bulb. It is a random variable which is exponential distributed, continuous random variable. For that kind of problem, how can you solve it? For that we need a random variable x. Today I am going to explain what is random variable and how random variable will be used to solve statistics problems. Okay, now let us go to the slide first. So, are you able to see the slide? You please tell me, anyone of you tell me, are you able to view? Yes or no?
Yes, sir. Visible, sir.
Yes?
Visible, sir.
Visible. Okay.
Yes, sir. Yes, sir. Yes, sir.
Okay, thank you. Now let us say random variable and probability distributions. So this is my. So I have taken outline of the syllabus. I am going to deal all these things, but in a brief manner. Okay, introduction, random variables, probability, continuous random variables. With that, within that there is probability density function. You know why it is called density function? Because it is a continuous random variable. For discrete random variable, it is called probability mass function. Okay. Then what do you mean by cumulative distribution function? That is, what is the probability that the number of, when you are throwing a die, what is the probability that you are getting a number which is less than or equal to 5? For that you have to add the probability of 1, getting 1, 2, 3 up to 5, not 6. So you have to add all the possible probability. That is called cumulative. That is less than cumulative probability. Another one is called greater than cumulative. What is the probability of getting a number which is greater than 2? That means you have to add the probability for 3, 4, 5 and 6 in a discrete manner. If you do it in a continuous manner, you have to take an integration that is called capital F of x, integral minus infinity x f of x. Okay. Then another one is for mean and variance for a distribution. How can you find mean and variance? An important continuous, what are the important continuous distribution? Normal distribution, log normal, gamma distribution, variable distribution. And probability plots. How can you plot the probability? And in the question, when CSIR is concerned, a question is asked, you can immediately come to the answer only by plotting the probabilities. Okay, if there are 4 answers given, the best way to answer the questions in CSIR is concerned, intelligent elimination of wrong answers. If you are out of 5 answers or 4 answers, if you are able to intelligently discriminate, eliminate the wrong answer, finally you can come to the correct answer exactly. Okay, and discrete random variable. Next, actually, discrete random variable first, and then, but in this case, we have taken the discrete. That is probability mass function. You look at this, it is probability mass function, then cumulative and mean and variance. And what are the important distributions? Discrete distributions are binomial distribution, Poisson distribution. And what is the connection between Poisson and exponential distribution? That will go. Then normal approximation of the binomial. A binomial distribution, the Poisson distribution can be approximated from the binomial distribution. How it can be done? And more than one random variables. Now let us take the next topic is, if there are 2 random variables, how can you deal with? X is one random variable, Y is another random variable. If X is the age of the person and Y is the intelligence of the person, is there any correlation between them? What do you mean by correlation? It is nothing but a strategic relation between these two variables. Okay. If the correlation coefficient is -1, that means there is a negative correlation. So one increment in one variable does not give the increment in another one. Okay. And therefore it is negative correlation. And positive correlation means an increment in one variable will rise to the increment in another variable also. If one is decreased, other is also decreased. There is positively, highly positive correlation. That is, suppose the correlation is negative, means they are no way connected. Okay. If correlation is 0 means there are perfectly no connection between these two. And functions of random variables. Another one is joint distribution. How can you find the joint normal distribution? That will give rise to your what is called correlation. Okay. Our correlation coefficient is equal to covariance of the function, covariance of x comma y divided by n into sigma x into sigma y. And another one is functions of random variables. If there are two random variables, you take the function of random variables, x square plus y square. What is the distribution of x square plus y square? What is the distribution of x plus y? That is also a function of random variable. Now, how can you deal with all these things? And last one is random samples and statistics. So this is my plan of lecture. Now let us start with, after completion of this course, what are the achievements you made? It is outcome based. You might have determined these are the objectives, learning objectives of this course. Okay, determine the probabilities of discrete random variables with the probability mass function, and for continuous random variables from probability density function, and use cumulative distribution. This is the first perspective. After completion of this course, you are able to solve discrete random variable problems, plate-oriented problem, and continuous random. And second one is calculate mean and variance of discrete and continuous random variables. Okay. And understand the assumptions for each probability distribution presented. This is very important. That is why in the last class I told you, big mathematicians or youngsters or you are a postgraduate student, most of the postgraduate students, I am not telling all of you, most of the postgraduate and research scholars, they understand probability problems as formula oriented. A formula is given, you can solve it. For everything, a standard formula is there. Okay, for distribution, mean, median, variance, and everything. For everything, there is a standard formula. You can just apply the result, apply the data, and get there. It is not so. Please understand, mathematics, probability is a mathematical model. Every model has some assumptions. Unless these assumptions are satisfied by your components, your parameters. Are you able to understand? Yeah, unless the conditions of the models are satisfied by the parameters involved in your problem, you cannot apply the formula. Because that is a statistical model, it is a probabilistic model. With that assumptions only, the formulas are derived. Suppose the assumptions are not satisfied, the formula becomes wrong. So that is why in mathematical problem, you are solving probability problems, each word has a meaning. You have a strong understanding in the language is very important. For example, at least and at most, these two words will split. Okay, it will give different answer, different probability calculations. At most one event and at least one event are different. And that is why this to understand the assumptions of each probability distribution. Select an appropriate probability distribution. That is also a technique. Under experience only, if a problem is given, which probability distribution you have to apply? That is very important. If you are able to do it, then you can count. If you are able to identify the probability distribution, whether it is Poisson distribution or binomial distribution or exponential distribution, which distribution I have to fit with this data, and if it is okay, and 50% of the problem is over. That will then standardize normal random variables. Sorry. Standardize random normal variables. Use stable or cumulative distribution to standard normal distribution to calculate this. Calculate this kind of problems will not be asked in the examination because using table within this kind of time is not possible. But even though this is approximate probabilities for some binomial and Poisson distribution, interpret and calculate covariance and correlation. This is very important part. Last year, 2019 question, the first question, I think it is question number 54 or something. This first question, a data is given, very simple data. X, a random variable, Y, a random variable. And I will show you. And find the correlation between two random variables. These kind of questions are asked in the exam. Okay, how can you find it? That is when the problem is very simple, you apply the simple formula. That is, correlation coefficient R is equal to sigma xy. You take x on data and y another data variables. Sigma xy minus sigma x into sigma y divided by square root of n into sigma x square minus sigma x the whole square into square root of sigma n into sigma y square n into sigma y square minus sigma y the whole square. This formula, you know, as you are all first graduate students, you know all these formulas. But the problem is the data given is not in a regular manner. It should have some trick. If you are able to apply the right trick, okay, what is the formula you should use? Suppose the mean can be computed, 5 values are given in a series type, okay, the increment is given as 2 or 2, 2, and then the central value you can take it as mean, and you can use the shortcut formula and get a random, correlation coefficient very easily. Okay, and then calculus of mean and variance of linear combination of random variables. This is another important one. If one random variable is given, two random variables are given, you find correlation and regression. If two random variables and their linear combination is given, and what is their mean and mean? This part, an approximate mean and variance of general functions of several random variables. It is multivariate calculus. And understand statistic. What do you mean by statistic? Your mean, standard deviation is a statistic. A statistic is nothing but a function of random variables. Random variables, it is sample data without involving any parameter. Other parameters should not be involved. Only it is the function of x1, x2, xn. Then it is called statistic. And what kind of statistics? Understand statistics and its distributions. Okay, now let us come to the next. Experiment, random and random experiment. I already explained all these things in the previous class. Now let us come to this analysis. If there is a physical system, first you do the measurement of the physical system and take the model. That's why I told you that model is a probabilistic model, and then do the analysis and apply it in the physical system. This is a continual iteration of process, and finally you derive you get the idea of probability. Okay, when your data is given to a system, people think that our output, you can get a system is good and your input is okay, and finally you get output is correct. It is not so. If your input data has some noises, then your output may be wrong and your interpretation may be wrong. Okay. Now I can give this kind of problem you asked in the exam. I can give a very simple case. That is, in a class, there are 10 students whose marks are given as 70, 30, 50, 70, 30, and 55, and 78, or something 0 and 100. What is the average? What is the average? You add it divided by 10. Okay. What is geometric mean? Arithmetic mean is okay. Geometric mean of this 10 marks. When you add all these values and divided by 5, you will get some value, some 55.7. So I can say that the average is 55.7. Okay, but there is a noise data. Suppose the data, one of the student got 0 mark. What is your geometric mean? Geometric mean is x1 into x2, etc. xn the whole power 1 by n. You multiply all these data and take the nth root. What is the value? 0. Do you agree? In a class, one of the student got 75 marks, one 50 marks, one 40 marks, one student got 100 marks, and only one student got 0. And unfortunately or unfortunately, all the average means geometric average. Geometric mean of the class is 0. Don't accept. So, when if the data is correct, without noise, your output may be correct. And therefore, these kind of questions you should expect in the examination. Which means, I can tell you the very simple thing, geometric, harmonic means, there are 3 kind of means. Okay. What are the 3 kind of means? Tell me. Mean, geometric mean, arithmetic mean, geometric mean, harmonic mean. Which is the best mean? Even now, this arithmetic mean is the best mean. Why? Even though there are so many noises in the data, because sometimes the data may be 100. One of the students may get 100, all the other students' marks are less, but the average will hook up. Okay. And even though that is the best average, whereas in geometric mean, one of the data is 0, it will become 0. And harmonic mean, you have to take the reciprocal. When you take reciprocal, when 0 data is there, 1 by 0 become infinite. So all these are considering all these things, which is the best mean? Actually, geometric mean is the best mean because it is at the middle. Best mean is decided by the central average. What is mean by central measures of central tendency? Mean, median, mode, or measures of central tendency. And so, which measure is the center is the best measure, and therefore, which is the best measure? Geometric mean is the best measure. But when noise comes, that becomes bad. Therefore, we are taking arithmetic mean is the best measure. Okay, now let us come to the next part. When you close the examination, you look at the model. If you take any system, at the long run, when you look at the larger level, it will be like this. Interpretation is something different. You look at there is a line. One data item here and there. But when you look at very close, they are on the same line. Therefore, the linear regression is nothing but fitting a line that will give you the correct data. Okay, this is another concept of mathematics. Now let us come to this point. You are observing a system, the queuing system or any, for service purpose, people are arriving. The first person is arriving here. After 5 minutes, second person is coming. After 5 minutes, another person is coming. And this is time. Okay, and this is the regular one. But if there is a small change, small variation, the first person comes here, his service is completed here. Okay, his service is completed here. Oh, he left the place. You can consider this as a queuing system. And the remaining time, the server is free. The second person enter exactly at 5 o'clock and he is getting a service for a long time. His service is not yet completed. But therefore, the third person comes at the minute 10th, his call is blocked. You can just look up your calling, okay, cell phone calls, and it's coming to the switching station, okay, and there is a difference. How much time? Now the question is, suppose a fourth person comes, whether he is able to get service or not. That itself is uncertainty. To deal such kind of problems, and you are studying probability and statistics. Now let us come to the main point, random variable. Why we need random and random variables? In an experiment, the measurement is usually denoted by random variable x. What do you mean by this x? I don't know. Usually we put x for a variable. Here it is capital X. People say that it is a function. In a random variable, a variable whose measured value can change from one replica of experiment to another is called a random variable. So, what is our actually random variable is a numerical value measured from replica of experiment. It is a discrete. If it is a discrete random variable, it takes discrete values. If it is a continuous random variable, it takes. So, random variable is nothing but a function from sample space to what? Real number. Why we need this transformation? Why you take the random variable to sample space to this? For example, I can give a continuous random variable. Yesterday I gave an example of time, that is lifetime of a bulb. Temperature is a random. These are all continuous random variables. Voltage, weight. And discrete random variables, number of defective parts, number of success. When you are throwing a die, you are fixing 6 success, number of success. All these are discrete random variables. Okay, number of items in, suppose you enter into a business. In a business, those people are having inventory. At time at 11 o'clock, you enter into the shop. How many TVs are there? So it's a random variable. It may be 1 or 5 or 10. These are discrete. You cannot say that 1.5 TVs are there. So that is discrete random variable. Okay, now let us come to the main point. That is why we need a random variable x to deal with probability computation. What is random variable? If x is a function from omega to r. R means set of real numbers. Sometimes it may be negative also. That is why put the negative. It's a measurable function. It is overall measurable function. Why we need this random variable? That is the question. Because when you are throwing a die, what is your outcomes? Head or tail. This is your sample space. This is omega. And then what is this set? This is nothing but the 1 and 0 is a subset of R, real number. Now we are heights. I am taking a random variable x, transform. I am taking a random variable to transform this heights to 1 and t to 0. Why we need these random variables? Because for a random variable, these outcomes are in English letters. You look at the another experiment, second experiment, where when 2 coins are thrown, you are getting what are outcomes? Head, tail, head. These are in English letter. For example, you throw a die and coin together. What are your outcomes? The die, you will get 1, and the coin you can get 1 height, 2 height, 3 height, or 6 height. Or 1 tail, 2 tail, and these are. So the English letter as well as numbers are put together. Okay, this is not uniform. Your sample space is not uniform. It means in some cases it is English letter. You are representing the outcome by English letter, and sometimes 2 English letters, sometimes 1 English letter and number, and you want to uniformize this. If you have a common platform, your problems will be solved very easily. You can understand the problem very easily and quickly solve the problem. Okay, for that purpose only this random variable is introduced. So, since the sample space are not regular, they are not uniform, and you have to transform, you are able to transform this ununiform situation to uniform situation. Then uniform situation means, which is the uniform space? Set up of real numbers is a highly regular uniform space. It runs from minus infinity to infinity. It will include all, you can do all kind of computation there. Addition, multiplication, division, everything, all computation can be done. Here the computations are not so easy. You cannot add h plus t. You cannot add 2 numbers just like your. So, your set of a real number is an amenable space for which you can do any kind of problems. Any real life problem comes with a random variable. You are able to represent it by a random variable and you can solve it very easily. That is why this random variable, a function, that what is the beauty of the function x? It transforms as sample space to real space. That is it. Okay. And if you are able to understand this, then your 25% of the problems on random variable concept is over. Now let us come to what is probability. Now you have to compute probability. What is the probability of a random variable x equal to 1? It is used to quantify likelihood or chance, to find the chance of occurrence of that event. So now you can represent, after defining the random variable x, you can represent each random variable, each event by a random variable. So instead of dealing with event space, now you are dealing with x, random variable. And then your computation can be done by relative frequency, number of favorable cases by total cases. What do you mean by probability statement? It is nothing but a likelihood. That is why likelihood function that we have studied, that is in inferential statistics. There are two kinds of statistics. One is descriptive statistics, other one is inferential statistics. Descriptive statistics, we study measures of central tendency. What are the measures of central tendency? Mean, median, mode. Within mean, there are three: arithmetic mean, geometric mean, harmonic mean. Then standard deviation, measures of dispersion, that is standard deviation, mean deviation about mean, range, all these things are measures of dispersion. And all these things we can compute. Okay, and correlation, regression, all these are descriptive statistics. And then you come to inferential statistics, take a data, sample data, their sample distribution, the H-score distribution, T distribution, F distribution. According to that distribution, you make a statement. That statement is also a probability statement, that is likelihood probability statement. And from that statement, you have to collect data and verify that statement is significant or not. It is true up to 95%. It is 90. Can you believe it? 95%. Therefore, in 5% case, we cannot believe it. Okay, some error may occur in 5%. The likelihood is quantified by assigning a number in the interval 0 to 1. So it is a probability statement, or 0 to 100%, that means. Higher numbers indicate the set of values more likely to acquire. If you get the probability is 0.9, that means your statement may be correct. Now let us come to probability is used to express in terms of random variables. Probability, how you can express probability in terms of random variables. I already told you random variable is nothing but a function from sample space to R. What is x of s? You take s from omega, x of s is an element in R. It's a real number. So I can take probability x belongs to, it's a real interval. 10.8, that is equal to 0.5. This is the statement. What is the meaning of that? The probability of the random variable belongs to this interval. The value of the random variable belongs to this interval is 0.25. Then what is the case in the other 0.75 case? 0.75 cases, in 75% of cases, the random variable takes the value from minus infinity to 10.8 and 11.2 to minus infinity. Two extreme end, tail end. Now look at this. X lies between 10.8 to this is equal to 0.25. Both equations state the probability that the random variable x assumes the values 10.8 is 0.25. So this means in 25% of the cases, the value of the random variable x lies in this interval. Okay. Now let us come to what we mean by complement of the event. If E is an event, E dash its complement. Okay. Mutual exclusive, all these things, I cannot explain all these things. Mutual exclusive means E1, E2, EK are mutually exclusive events whose mutually exclusive and exhaustive means E1 union E2, EK is equal to whole omega. That it will exhaustive. There is no other. And mutually exclusive means occurrence of E1 reject occurrence of E2. Occurrence of E2 reject this. These are disjoint. That means these are disjoint events, and E1 occur means E2 does not occur. For example, when you are throwing a die, if 1 occurs, 2 does not occur. If 6 occurs, 3 does not occur. Okay, all are mutual exclusive. If there is an event, you take E1 is equal to 1, 2. E2 is 2, 3. These two are not mutually exclusive because 2 can occur in both cases. Okay. Now let us come to our probability. This I already told in the previous class. That is probability. The properties are probability x long. Now I converted it into this is a probability set function. I converted by involving random variable x belongs to R is equal to 1. Why I put to the probability 1? Because x is a random variable which can take the values throughout the R. It cannot escape from R. Okay, if x belongs to R means it takes all possible values. Therefore, there is no chance its probability is 1. Then usually you take E is an event. If x belongs to x of s belongs to event, this event is nothing but a subset of R. Because the whole sample space has been transformed into R. Your event also, event set, I already told you the event set is nothing but is a class of sets which satisfy some condition that is called sigma algebra, and that members of sigma algebra is converted into what? It becomes a subset of R. It may be an interval or closed interval, open interval or semi-open interval, whatever it may be. Probability x long 3 lies between 0 and 1 for any set E. This E contained in R. It is not given. Okay. Now let us come to if E1, E2, E are mutually exclusive events, probability of x belongs to E1 union E2 UK is equal to sum of these probabilities. How this comes? This is nothing but their countably additive property that I wrote yesterday. Countably. It is, but actually it is given for only k sets. It can extend to infinite number of sets. Countably infinite set it is true. And countably additive property is there. And if these three properties are defined, is satisfied, I can clearly say that the space is probability space. What is the name of the space? Omega P. And your sample space and your space A, C or A script A is a collection of algebra. Okay, collection of all subsets of this R. Now let us come to the next one. The measured value is not always obtained from an experiment. Sometimes the result is only classified into several possible categories. So, problems can be categories are often referred as events. So, your desired event that is defined in an exact manner and divided into so many categories, and the event should be selected. If you are able to select the event from the different categories, now then you can find the probability very easily. So, sometimes actually it is 0, 1. Now we are dealing with 0, 1 logic. That is, if you take a random variable, it belongs to the set A, script A set or not. If it belongs to A, the probability is there. If it does not belong to, there is another probability is there. Okay. We cannot take the low, medium, high, this kind of logic will not work. This will work in fuzzy logic, fuzzy set theory. Now let us come to the probability distribution. Let x be a random variable and omega is of sample space, and after the description how the probability density function. What do you mean by probability density function? What is the possibility that x lies between A and B, and A and A plus I can take actually if you put this x lies between, you take is here x and x plus del x. You take A as x and this B as x plus del x. What is the probability that random variable lies between a very small number, x and x plus del x? X means small x plus 1. That x and x plus 1 x are numbers on the real line. Okay. X and x plus 1 is a very small interval, delta x is a very small quantity, and that is almost the point x. That is nothing but f of x. That is your probability density function. Probability that random x lies between x and small x plus del x, that is f of x. Therefore, I can extend this concept from A to B, any A to any B on the real line, and it will become integral A to B f of x. You take the sum of all these density values. and finally, and that is good. Okay, here I remember, I will explain again. What is this density function f of x? F of x is nothing but probability that random variable x lies between small x, that is this x and x plus del x. That is very small interval. X lies in the very small interval, that is almost x equal to small x. What is the probability that capital X equal to small x? That is your f of x. And then you have to find the probability between a larger interval a to b. A may be 1 and b may be 5. 1 to 5 is a large interval. Okay, infinite number of numbers lies between b. And what is the probability? That is integral a to b f of x dx. And this f of x, what is this f of x? This is always positive. What is the total probability? Minus infinity. Sum all the possible distribution. This is nothing but probability. Probability density function. Because it is so dense. Here I have to mention another important thing. What is the probability density function at a point, at a particular point 1 or 1.5? On the real line, it is 0. On a particular point, it is 0. It is not defined. It is defined only on a small interval x comma x plus del x. Okay. It cannot be defined on a particular point. At a particular point, the density function value is always 0. You should be very careful. Therefore, integral a to a f of x dx, what is the value? 0. Okay, f of x is positive and integral minus infinity f of x equal to 1. And these are the, if the density function satisfies this condition, if a function satisfies this, and it is called probability density function. Okay, next. How the probability density goes? It is a irregular function. Okay, it is loading on a beam. If you take a beam, load is slowly increasing. Just like that, the probability is also slowly increasing. Okay. Now let us come to this. This is our probability density function. Sometimes the probability density function will go above the x-axis, then it comes to 0. For a normal distribution, what happens? It is just like a bell shape. Okay, symmetry is there. Sometimes symmetric about the line x equal to mean. Some probability, standard probability distribution, standard normal distribution is symmetrical about y-axis. Y-axis, that is x equal to 0. General distribution, x equal to m, it is symmetrical. And this is not general, it is most general probability density function. It's like this. Then what is the probability lies between a and b? That is given by this area. Integral a to b. What do you mean by integral a to b f of dx? It is nothing but area under the curve f of x, and below the two ordinates x equal to a and x equal to b, and above the x-axis. Okay, and so this area represents probability. So this is the beauty of mathematics, where random variable, beauty of random variable, and that can be used in for application purpose. Your probability can be converted into area by the use of this random variable. That is why we introduce random variable. This is not possible when your sample space looks like awkward, like h, ht, h comma t. All these awkward things can be removed. How that awkward can be removed? So that is by defining your random variable in a systematic way. In the first case, when you are throwing a coin, head and tail, how I define my random variable, I have not mentioned that. X denote the number of heads. So when you are defining, it is not always number. I might decide even this head. That is why I am defining. Let the capital X denote the number of heads when throwing a coin. But someone else may define let X denote number of tail. So both models are same, but you will get different answers. But the problems, when you solve the problem, the probability of the particular event is always same. So that is why beauty of probability is it is symmetric. Whoever define, whatever you define, if it is logically defined, you will get the same. Okay, in the second case, so I will go to here. Let the x denote, I can define x. How can you define x? That itself is a problem. You can define your function. People are taking always, you may take f of x equal to x square or x square plus 1. There are polynomial function, exponential function, logarithmic function, so many other functions there. I'm simply defining here it is a discrete value, discrete variable. I define x as a number of heads of time. Here, how many heads are there? 2. Therefore, I match this to 2. Here, x denote number of heads when two unbiased coins are thrown simultaneously or one by one, whatever it is, because they are independent events, independent experiments. And h it is 2. T. Here, x denote number of heads. So, how many? Here, only one head. Here, also only one. These two have the same value, 1. And tail, these two have the same value because there is no head. But I am counting only head. Therefore, its value is 0. Suppose I define the random variable x as number of tails, this becomes 2 and this becomes 0. And the way in which you approach the problem and your random variable will change. Your random variables are not defined by somebody else. The problem solver himself has to define. If you define the random variable properly, and 50% of your problem is solved. Okay. Now let us come to this is x is a random variable, and f of x is this is x value, and this is f of x value, probability density function, and this is our probability density curve, and this a to b integral a to b f of x dx is given by probability a less than x. This is equal to integral a to b f of x. This gives the area under the curve, and this gives you a probability. Now let us look at another important thing. What is the probability that minus infinity, you take minus infinity to infinity, f of x dx, that is equal to 1, because the total probability is 1. Now, probability density function histogram. This is a histogram, and the density function, it gives, there are so many histograms, and all the histograms are joined together, that gives you a probability density function. Okay. Now let us come to the next important point. The probability of x lies within x less than or equal to x is equal to x. All these probabilities are same. Why? Because there is a difference in the interval. Here it is not equal. Here there is not equal. Both sides equality is not there. But even though all are equal. Why? That is why I told you at a particular point the probability density function has no value, 0. Therefore, it cannot be considered. Okay. So at this point, x1, if you include or exclude, it will not affect your original value. Okay. Both less than or equal to this and this, the open interval and closed interval have the same probability in that sense. Okay. Now let us come to that problem. I am going to give you an example problem how you have to approach the problem. Okay, you take a magnetic disk. You know, you are dealing with magnetic disk, you are storing information on a disk or tap or whatever it may be. The disk is always a circular region, and there will be a region. Okay, there will be rings. There are so many rings, and each ring area will store some message, your song or whatever, your data and everything. Now the problem is, at a distance, we are finding there is a defect. There is an error, there is a flaw in the disk at a particular distance from the origin. From the origin, at a particular distance, there is an error. The distance, you don't know. I take the distance from which, the distance from the origin to that track, that particular track, as a random variable x. Okay, and this is in micrometer. Because the problem is, the problem is not in centimeter or meter or something. It is micrometer, very small thing. Okay, now let us see. Let us consider random variable x to denote the distance in micrometer from start of the track on the magnetic disk until the first flaw. In the globe, that place, there is a first flaw. After some time, there may be another flaw. After some time, there is another flaw. There are so many flaws. Now we are looking at the first success. Finding a flaw is the first success. When you are throwing a die, getting number 6 is your first success. That success may not come immediately. It may come at the first throw or second throw or 10th throw. Sometimes after 100 throws, 6 will not come. So it is a random variable. Then X denote the distance of micrometer. Historical data shows that we have taken so many data and come to the distribution of X is modeled as this. What is the distribution? This is a particular type of distribution function. The random variable X takes this particular kind of distribution. This is identified by after so many experiments, so many historical data tested. What is the name of this distribution? Tell me, any one of you. What is the name of this distribution? This is exponential distribution. Alpha in e power minus x by alpha. Okay. Alpha into e power or 1 by alpha into e power minus x alpha, whatever it may be, you can do. Here I can take my alpha value is equal to 2000. So this is exponential distribution. It varies from 0 to infinity. Okay. Its mean is lambda. The lambda is this 2000. So this we can do. How can we solve? What is the problem? For what proportion of disk is the distance to first plot? Now, what proportion of disk is the distance to the first plot greater than 1000 micrometer? This means that actually the problem is what is the probability that I would like to say what is the probability that the distance of first flow is greater than 1000 micrometer. That means up to 1000 micrometer there is no flaw. The flaw occurs only after 1000 micrometer. What is the probability? Proportion means it is probability. Okay. What is the probability? That is, you have to find probability that x is, what is x? X is a distance from the first drop to error area, flaw area. That is, what is the probability that x is greater than 1000? This is very simple because your distribution varies from x varies from 0 to infinity. But here your value, minimum value is 1000 to infinity, f of x dx. What is 1000 to infinity? What is the f of x that is given here? 1 by 2000 e power minus x. You solve it. E power, what is the integration of this? E power minus x by this into minus 1 into 2000. That 2000 will cancel and you will get this. Put the limit. E power minus 1 by 2. The answer is 0.60. That means in 60% of the cases, be very careful statement. In 60% of the cases, the distance, the first flaw occurs more than 1000. So there's more probability. There's more probability, it is more than 5. That means in most of the cases, the error occurs after 1000 micrometers. Okay, what proportion of what between 2000 and 1? What is the probability that the error occurs between 1000 micrometers and 2000 micrometers? That you have to find the area between 1000 to 2000. Take integral from 1000 to 2000. And that is equal to e power minus 1 by 2 minus e power minus 1.2. This is minimum. Only 0.2. The probability is very less, and within the error, the first flaw occurs between 1000 and 2000. The error. Therefore, total area. Now we can find what is the probability that there is an error within 1000 micrometers. That is probability that x is less than 1000. Probability x is less than 1000 is equal to 1 minus probability x is greater than 1000. That is equal to 1 minus 0.607, and that is 0.3 something. 318 or 9 or something. That 0.393. Okay, now let us go to, I think you understood this problem and how to use random variables. I have already told you random variable is nothing but a convenient function to transform our sample space to real space. Why we are transforming? Because your sample space is not in a proper manner. Okay, it is an outcome of an experiment. That experiment outcome may be denoted by different kind of symbols. It may be English letter or mathematical, some other Greek letter or some other letter or numbers, all these things. When you are throwing a die, what are the outcomes are represented by numbers only, one on one. When you are throwing two dice, the outcomes are represented by tuples, ordered tuple of numbers. So all these are different. Therefore, it is essential to transform this data, so this sample space to real line. Then we are very much convenient, because on the real line it's very much amenable for all the operations, all kind of arithmetic operations. That is why we are doing this. Now let us come to look at this figure. This is 1 by 200. When, because when you put 0, x equal to 0, e power minus 0, what is the value? This is 1 by 2000, and this value. Okay, at 0 level is slowly the probability density is slowly coming. This is 1000. Here it may be 2000. Between 1000 2000, what? How much you got? Only 0.3 or something. Okay, 0.239. The probability of acquiring, probability of chance of occurrence of the first law between 1000 and 2000 is only 0.23 something. And probably it is right, it's less than 1000. Less than 1000, the error occurs within less than, it is 0.3 and something. Okay, all these are. Now let us come to cumulative distribution. What I mean by cumulative distribution? There are two kinds of cumulative distribution, that is less than cumulative distribution and greater than cumulative distribution. But in this case, usually in our book we are taking less than cumulative frequency distribution. Actually, it should be mentioned here, less than cumulative distribution. Usually it is standard throughout the world, people take cumulative distribution means less than cumulative distribution. That is why x is less than or equal to x. This is less than cumulative distribution. But what is the probability that your random variable is less than or equal to x, less than or equal to 10 or less than or equal to 100? This x is a variable. You can put x 10, x 100 or 200, 250. This is nothing but you have to take, because x is a random variable whose values are from on the real line, minus infinity to plus infinity. So what is the lower bound of x? Minus infinity. So that is why your integration starts from minus infinity to x, f of u du. So you add all the density function at each point, each interval. It is not each point. At each point, this probability is 0. At a particular point, it is 0. But when you consider this an interval, at each small, this interval can be divided into so many small intervals. At each interval, this has meaning, and take the sum. This integration is nothing but a continuous sum. You are taking a continuous sum. Therefore, for x varies from minus infinity to infinity. Very careful. This x varies from x value may be minus infinity. Then the integral go minus infinity to infinity. It becomes 0 and go up to infinity. Okay. Now let us come. Now what are the properties of f of x? You see this function, probability density function is ordinary function. It may go up and come down. It is just like ordinary function. Whereas f of x is not like that. Capital F of x is cumulative. You are adding, every time you are adding the probability. When you are adding the things, it is always increasing function. It is monotonically increasing function. Its final value is equal to 1. It will touch the line 1. Okay, what is f of infinity? It is 1. F of infinity means you put x equal to infinity, integral minus infinity, infinity f of u du is equal to 1. What is f of 0? Sorry, f of minus infinity? It is 0. F of minus infinity is 0. F of infinity is 1, and it is a monotonically increasing function. Now look at the figure. Sorry. Okay. Already we have exponential function. In the previous problem, we have seen an exponential function. For the same exponential function, what is the distribution function? F of x is equal to integral minus infinity to x put that function, that is 1 by 2000 into e power minus x something, and you put the value and finally you get this. It's like 1 minus, it is nothing but 1 minus f of x and x greater than 0. So f of x is shown in, and if f of x is 0 for x less than or equal to 0, because it will, for x greater than 0, 1, it will take value. For x greater than equal to the negative values, f of x is 0, and it is increases up to 1. It is a monotonic increasing function, increases up to 1. There it becomes flattened. And now look at this. It is an increasing, f of x is a monotonically increasing function, flattened at 1. It cannot go up before 1 because total probability is always 1. Okay. It starts from 0, monotonically increasing, cumulative. You are adding 1 by 1. Okay, adding the probabilities time by time, and it will go up to 1. The maximum probability is 1. Now let us look at the random variable is the distance until the first surface plot with the distribution given by f of x. The request, what is the probability? The random variable is the distance. What is the, now let us take the same random variable. Let x denote the, that is why I told you random variable is not a fixed one. For problem to problem, you can define in a different way. In first case, I will x denote the number of heads. Another one can define x denote the number of tails. And we will get, because both of them have the different purposes. Okay, he is counting, he is giving importance to head. Another one is giving importance to tail. But now we are taking the next example. Here also the same distance until the first class. Same random variable we define. And what is that? F of x. What is probability x less than 1000? We have to find probability x less than 1000. That is, what is the meaning of this? F of 100. Now you look at this. Actually, in your definition, probability x less than or equal to small x. We have put probability x less than or equal to x is equal to internal minus m. But here it is less than. Is it affect? No. Because at a particular point, what is the probability? Value is 0. Density value is 0. Therefore, it is not counted. Okay. Here we can put probability x less than 1000 or less than or equal to, both are same. F of 100, 1000 is equal to 1 minus, we apply that formula. Minus 1 by 2 into the 100, then 2000 into 100, 1000 will cancel and the answer. You get the same answer. Are you clear? Probability x less than. Then, now use, what is the probability that 2000 is less than x? What is the meaning of that? X is greater than 2000. So the first plot acquire after 2000 only. That is 1 minus probability x less than 100. This f of 100 will get that. Then, so now we are recalculating. This is nothing but recalculating the things. Probability that x lies between 1000 and 2000. This we have already calculated, and this can be used by distribution. This is not, now you must remember one thing, there is a distribution function, probability density function is different from distribution function. You can define probability distribution from distribution function. You can define probability density function from distribution. Both ways it is true. First you define probability density, then we go for density function, distribution function. Otherwise, first define distribution function, then come to this. Both way it is true. Okay, now I am coming from this side to this. F of 200, 1000, that is 1 minus, and finally you get the answer. Okay, now let us come to the next part, mean and variance or expectation. Mean is called nothing but expert value. What if x is a continuous random variable with the probability density function? What is the mean and expert value of x? Mean is equal to E of x. Expert value of x is nothing but mean. That is integral minus infinity and x and f of x dx. Now there is a problem. That is, this will exist at any case. In some cases, it will not exist. So this is nothing but our Riemann integral. Please be remember, This is the Riemann integral. This Riemann integral exists only when this f of x is Riemann integrable. Suppose in some case this function f is not Riemann integrable, automatically this will not exist. Therefore, you should have a condition, you should have a, if it exists, you should put a condition here. Integral have to be x f of x is if the integral exists and finite, then it will become finite less than infinity. Now what is the variance of x? Sigma squared is integral x minus mu whole squared f of x, and take the variance. And when you take the variance of this x minus x square, then 2 into x into mu x square, that will cancel. Then mu square into integral that will become 1. Therefore, this will give you the value x square. This is a shortcut method. So this kind of problem is asked in the examination. You should not do this and integrate. Just to take this one. This will give you the quick answer. If mu is known, x square into f of x dx, you compute this and then subtract mu square, immediately you will get. You need not go for these things and expand and get the answer. Okay. This is called standard deviation. What do you mean by standard deviation? Standard deviation. So how much the central value, the x bar, your mean is deviated from your data values are deviated from the central value. So this is your usual value. This is mean. How much it is deviated? So x minus mu. Why you are taking square? How much it is deviated means sometimes the deviation may be positive, sometimes it may be negative. So you put the average of that, sometimes it will become 0 or sometimes negative. But I need only positive deviations. That is why you take a square. So I take all the positive deviations, square it all the values from positive deviations. And that is why I am taking square it and then multiply with the corresponding probability and this will give you sigma square. But what is standard deviation sigma? And you have to put a square root. To find sigma, you have to put a square root of it. Why you take a square root here? Because when you are squaring a number, then value will increase. But actually we need the deviation from x mean, the original data and mean. But to convert it to the positive value, we have taken a square. So the square effect can be taken out. For that you have to take a square root. Are we clear now? So that is why standard deviation is a right technique. So for to take only positive, you are taking positive values, deviations, and for that you are taking the square, and you have to reduce the effect. You take square root, it will become sigma. That is your standard deviation. Are you clear? Okay, now let us come to the next point. And then what is exit value of x? I think this is we'll take this capital X. Here you should put capital X only. Exit value of capital X. What is, let x be a random variable. And the expected value of x is nothing but mean of the random variable. Okay. That mean can be computed. This mean, how can you find the mean? Suppose when you are throwing a die, this expected value need not be a real value. Sometimes it will give a distorted value. I can give a very simple example. You take, when you are throwing a die, what are the outcomes? 1, 2, 3 or 6. What is the corresponding probabilities? 1 by 6, 1 by 6, 1 by 6. What is the expected value of x? Let x denote the number on the, I'm defining a random variable that when you are throwing a die, let x denote, sample space is 1, 2, 3, 6. Okay, omega is equal to 1, 2, 3. I have to define a random variable, let x denote the number shown on the face of the die. Okay. Now let us come there. That is your, what is the expected value of x? When you are throwing a die, what is your expectation of that number? Is expected value is equal to sigma, sigma x into f of x into dx. What is your x? 1. What is the corresponding probability? 1 by 6. 1 into 1 by 6. 2 into 1 by 6, etc. Okay, take 1 by 6 outside, 1 plus 2 plus 6. 6 into 6 plus 1 by 2. Therefore, 6 cancels, 7 by 2. What is the answer? 3.5. Your expected value of the random variable is 3.5. Whether when you throw a die, can you get 3.5? It is not so. But this is only an approximated value. This is our expected value. This is our, but in real it may not come. It may come 3 or 4. Okay. So even though this will give you a mean value, approximate. And x into f of x into dx, x into you put f of x e power minus 1 by 1 by 2, answer it and find what is the value? 2000. The expected value is 2000. That's why I told you, you put this 2000 is, I can take this 2000 as lambda. In an exponential distribution, what is the probability density function f of x is equal to 1 by lambda into e power minus lambda x. 1 by lambda into e power minus lambda x. What is the lambda? 2000. Therefore, exponential expected value of x is equal to lambda, that is 2000. And what is the variance? The variance is also lambda. You should x minus mu whole square, 2000 whole square, and now you take the root, square root. What is your answer? Again 2000, that is your lambda. So this is the only distribution, exponential distribution in which variance and these two are same. Okay. And then come to normal distribution. And this is the most used distribution. And why we are using all this? If you take any data, whatever be the data you collected in the real life, and most of them are normal distribution. That is why when you are applying normal distribution cases or testing the hypothesis, first you should test normality test. Your data is normal or not. For example, I can give a very simple example why we took all these are normal. When you conduct a test on statistics or mathematics for 50 students in a class, you put the mark in the sheet. You look at this, how it occurs. That is 0 to 10. How many students will get the mark from 0 to 10? The maximum mark is 50. Okay. 0 to 10, only 2 or 3 students will get. 10 to 20, some 5 students. 20 to 30, some 7 students. Then 30 to 40, some 4 students. And 40 to 50, only 1 student. Is intelligent student. So it is just like a pencil. So whatever may be the data you have taken in a real life, always it is normal. That is why this normal distribution is more important. You are going to use it in most of the statistical problems. Now let us come to central limit theorem and Gaussian distribution. These are the very important theorems. Central limit theorem is a pin of the kingpin of the theory of estimation or inference theory. Statistical inference theory, central limit theorem is. What is actually central limit theorem? Whatever means a huge data, huge world of data, you take a sample, that sample mean is nothing but the original mean. The sample mean is equal to the original as n times infinity. The number of data are increased and their mean and this mean are always same. Only there is a small difference in the standard deviation, that is for your whole world. That is, I can take the whole world, that we can call the population. I call it as the whole population. If the population standard deviation is sigma, your samples may be sigma by root n. Because we are not dealing with the whole data, we are dealing only a small sample of portion of people, that n, therefore root n. Okay, central limit theorem and Gaussian distributions are very important, that I will deal later. And you look at this. The normal distributions are like this. Mu is equal to, or this case, mu is equal to 5. It is at the center, this bell. This represents a normal distribution. What is the probability density function of normal distribution? F of 1 by sigma root 2 pi. What is the sigma for this? 3. For 3 root 2 pi e power minus x minus mu the whole square. What is mu? That is x minus 5 the whole square divided by 2 sigma square. Divided by 2 sigma square, 2 into 9, 18. So that will give you this curve. And what about this curve? Mu is equal to 15. The central value is 15. It is symmetrical above this line, the ordinate x. X equal to 15. Okay. And sigma square equal to 1. Therefore, what is the distribution function of this? 1 by sigma is 1 by sigma 1 Therefore, 1 by root 2 pi e power minus x minus 15 the whole square divided by 2 sigma square 2 into 1 2 divided by 2. That is this curve. Now look at this curve. This is highly peaked curve. Sigma square is equal. The variation is less. That means the variation from the central values are very less. That is why it is very much peaked. Look at the data. The central value is 5. All the data values are very close to this central value. But here it is not so because it is deviated. Why? Because sigma square is 9. What is the purpose of sigma square? It's variance. The data are highly varied from the central value. That is why this flattened curve. And this curve is steepened curve and sigma square. Okay. Now with this, we'll come to. You look at this. This is our probability. What I told you. 1 by sigma root 2 pi. Sigma is not within root. Usually sigma should be put here. Sigma root 2 pi e power x minus mu the whole square divided by 2 sigma square. What I do? Minus. This is called normal distribution and this random variable is called normal random variable. With 2 parameters. Here, now you look at this. In the previous case, we had seen what type of distribution we solve the problems with exponential distribution. There exponential distribution, there is only one parameter lambda. There the lambda is 2000. I already told you 1 by lambda into e power minus lambda x. That lambda is 2000. Okay. That is not mentioned there. 1 by lambda into e power minus lambda x where x greater than or equal to 0. Lambda is positive. Okay. And that is a exponential distribution. Here, there only one parameter. Lambda is the only parameter. When you take mean, it is lambda. Standard deviation, it is also in terms of lambda. Whereas here, there are 2 parameters. Therefore, normal distribution is something different from exponential distribution. This exponential distribution, normal distribution has 2 parameters. It depending upon 2 parameters, that is mu and sigma. So mu lies between minus infinity and infinity. But sigma is positive. Okay. But sigma square lies between 0 to infinity. Okay. And the x, what about x? X varies from minus infinity to infinity because it is symmetric on both sides. Okay. And what is x value of x? Mu, variance, and both are given. Okay. I think we can stop here because time is almost 12:15. And if you have any doubt regarding my previous lecture and this one, and now I am going to show you. So the last minute you have. After that you can ask questions.
Sir, only one question, sir.
Which one? Was? Tell me.
What is the drawback of correlation coefficient?
Correlation coefficient.
Yes, sir.
What is the drawback? Correlation coefficient.
Yes, sir.
So it will give actually correlation coefficient. It is nothing. It will give a causal relation between these two. It will not exactly give the relation between x and y, the random variables x and y. Okay. It is only only represent a relation between these two. It is minus 1 and plus 1. You cannot exact, but actual relationship between the random variable x and y is given by regression analysis only, regression coefficient. But correlation coefficient, sometimes if you take the data, if there is a relation x and y, if you take the data, it's not causal, they're not related. For example, you take age, x as age of a person, and y as his height. These to have no relation, but sometimes people are taking these two things as data and do correlation, and finally your correlation analysis will go wrong. So, if there is a causative relation between X and Y, then only you should apply correlation. Otherwise, you should not apply correlation. Okay? Are you able to, you please read the statistics book by Alexander Moore, Introduction to Theory of Statistics by Alexander Moore. You can understand this concept. That is, if you take two random variables and you cannot take any two variables and do correlation. Correlation is analysis by it gives a tentative relationship between two random variables. Okay, if there is no causative, if one cause, y is the cause of, y is the cause of x, and x cause is the cause of y. If that relation is there, then only you can apply your. Otherwise, it will not work. Okay, that mistake is done by so many biology, other science stream people, and they are taking any data in the lab. They are taking any data, regarding this research and everywhere, taking any two data and then correlate it and write a interpretation that is wrong. Okay. So, any other question?
No, sir. That's all, sir. Thank you, sir.
I would like to, okay, well, I would like to show you the only that is question recently and CSIR question. I'm going to show you a question from CSIR. I think, are you able to see this question? I'll elaborate it. You come to question number. So, how statistics questions are asked. I'd like to show you. Look at this question number 49. The pair of observation on two random variables x and y are 2, 5, 7, 11, 13, 19. Why? This is a question asked in 2019. Okay, CSR question 2019. I have forgotten the name. Okay, I think it may be 19 or 18. 2, 5, 7, 11, 13, 19, 0, 15, 25, 45. Then the correlation goes between x and y. How can you compute it? So you apply the formula. So you have a quick computation sigma xy minus sigma x into sigma y. You add the data very quickly. Divided by square root of n. N is 6. N into square root of sigma x square. This computation will be, but for that the squaring a number and all these things can be done very quickly. Otherwise, you go for the shortcut method. You find the mean of the thing, and from that you compute it. Okay. And another next question. Let x1 x2 independent random variables. Probability of xi is equal to +1, xi is equal to -1, equal to 1 by 2, and y1 is equal to x2, x3. y1 is a function of x2, x3. That we will deal in the next class. Okay. y2, product of these two. y3 is the product of these three. And which of them is not true? So these are a very complicated question. So here you have to eliminate. That's why I told you, you eliminate the question which is not true. Which of the following is not true? Okay, ya and xi are the same distribution. Is it true or not? This is not true. Okay, therefore, which of the following is not true? You have to identify the thing and then identify the distribution. Then you have to. That is very simple because the random variable. I will give a simple flow. Random variable has real value. That is why I told you. You multiply these two. +1 into -1 minus. Okay, so we -1 into -1 plus, it will give another value. So if you have idea of this, you can solve this kind of problems very easily. Okay, Thank you. I close this session. Its time is almost over. We can discuss all these problems in the next class. Any questions?
Sir, no questions, sir.
Okay, we can close
Thank
the
you, sir.
session.
Thank you, sir.
Thank you. Thank you very much. We can see you next.
We wish to express our gratitude to our resource persons for being with us on this event. Your explanation is very useful for all of us, sir. Thank you so much, sir. I would like to thank Professor R. Venkatramanan, Head PG and Research Department of Mathematics, for organizing this C4 workshop. I am very proud to inform about our next program, our next national level webinar titled PASI Mathematics Application and E-Resources. Resource person Dr. T. Bharati, Assistant Professor, Department of Mathematics, Loyola College, will be held on 3/4/2021 at 10:30 a.m. And our next C4 session will be held on 3/4/2021 at 6 p.m. Thank you. Thank you so much.